All right. So yesterday we had just started talking about what a radian is and how we measure angles in radians. And then we practiced converting from degrees into radians. So today I want to begin by going the other way and converting from radians back into degrees. So remember that proportion that we used to convert was that pi radians is equal to 180 degrees. So we can use the proportion of pi over 180 degrees or 180 degrees over pi to convert between those two. So I'm going to pop that proportion up here in the corner for us to use. And I want to know, on these problems, when we're wanting to go into degrees, which of those two proportions should we use? Should we use pi divided by 180 degrees? Or should we use 180 degrees divided by pi when I want to go from radians into degrees? Brendan, awesome. 180 degrees over pi is the proportion that we're going to use here. So for part A, I have 5 pi over 6. I'm going to multiply that by 180 degrees over pi. The units that I want to go into need to be in my numerator. In my denominator is what I want to cancel. So since we don't really ever see degrees with pi in them, I want to make the pi cancel out. So that's going to cross cancel. And then we're going to multiply straight across. So I'm going to do 5 times 180 degrees. What is 5 times 180? $900. So I'm going to have 900 degrees divided by 6, and 900 divided by 6 would give me what? $150. So 5 pi over 6 is the same thing as 150 degrees. I do want to point out that back here in this step, you could have looked at the 180 and 6 and said, oh, I can reduce that there. I see that those can both be reduced by 6. And so then you could have canceled that out there and you would have had 5 times 30 degrees, and you could have used that to jump straight down here. So you can reduce and then multiply, you can multiply and then divide. You just want to get to that final degree answer. When we're working in radians, unless it comes out to a whole number, we want to leave things in fraction form. But when we're talking about degrees, if it doesn't come out to a whole number, we're either going to put that in decimal form or we would do it in degrees, minutes, seconds. We don't really leave degrees in fraction form like we do with radians. I want you guys to do B on your own. And once you have an answer for B, I want you to send a direct message to me in the chat so that only I can see your answer with what you get for part B. Luke, that is absolutely correct. Max, that is correct. Jacqueline, Jacqueline, that's correct. Pedro, check one more time. Jay, that's correct. Miles, Simon, Brendan, that's correct. There you go, Pedro. They're starting to come in pretty fast now. Other than the one mistake that's been corrected, everything that's been submitted so far has been correct. All right, so let's run through this very briefly. You're going to do this one exactly the same as the last one. You're going to multiply by 180 degrees over pi because you want pi to cancel. Anytime we're going into degrees, we're going to have the 180 in the top. Anytime we're going into radians, we're going to have the 180 at the bottom. So then I'm going to multiply the 3 and the 180 degrees, and we will divide that by 4. 3 times 180, I want to say is 540. Yeah. So 540 divided by 4, and that should give you 135 degrees. Exact same process with part C when we have negative angles, negative radians. Doesn't change the fact that we're still trying to convert it into degrees. So I'm going to multiply by 180 degrees over pi. Pi is going to cancel. So I'm going to have -7 times 180 degrees over 8. Which would be -1260 degrees over 8. And what is that -1260 divided by 8? Type it into the chat for me. Absolutely correct, Kalia. -157.5 degrees. Absolutely right, Arisbeth. I want you guys to do D on your own, and just like we did with with B, when you get a final answer, I want you to type it into the chat, send it as a direct message to me for part C. Sorry, for part D, I keep misspeaking here. On part D, I want you to do it on your own and then type it as a direct message into the chat for me. Jacqueline and Pedro, that is absolutely correct. Tripping all over my words today. Miles, that's correct. Max, that is correct. I just had a whole bunch of them roll in, and everything that I've seen so far is correct. Arisbeth, that is correct. Absolutely right. Everybody that has typed in an answer in the chat so far has been correct. It is -54 degrees. -3 pi over 10. We're going to multiply that by 180 degrees over pi. Makes my pi's cancel out. It's going to give you -540 degrees over 10, which would be -54 degrees. Nice work, everyone. Before we move on, does anybody have any questions for me at all on how to convert Brendan? We absolutely could put that one in minutes and seconds. Technically, we would only need minutes. It'd be -157 degrees and 30 minutes. However, usually when it is a really nice decimal, like a 0.25 or a 0.5 or a 0.75, a lot of times that is close enough precision, but it would not be inappropriate to put that one in degrees and minutes. Good question. Good question. Does anybody else have any other questions for me on this? Yes, absolutely. If it came out to be like -157.2 degrees, I'd be totally fine with you leaving it like that. If I want you to convert it into degrees, minutes, seconds, I will make sure that that is part of the direction, that you know the type of level of precision that I'm looking for. Any other questions about this? All right. If you think of another question, please feel free to type it into the chat. We're going to talk about something called coterminal angles. These are angles that share a terminal side. Terminal side of an angle. What is the terminal side of an angle? What do I mean by that? Terminal side of an angle is where that angle does what? It's where it ends. Yes. Where the angle ends. They're going to have the same initial side. All of the angles that we are talking about are in standard position. And standard position means that shared initial side is where? Where is the shared initial side when we're in, Brendan, where on the x-axis? You're right, it's the x-axis, but where on the x-axis precisely? Positive side of the x-axis, yes. This is the positive x-axis, or the right side of the x-axis. When we're talking about terminal angles, you can make multiple rotations in either direction. One note about that, though, to be coterminal, you have to make full rotation. Why would that be? Why would you have to make a full rotation in order for it to be coterminal? Yeah, so that it can end in the exact same spot. All right, so I want to give a little example here, and then we're going to go practice with some other ones that I have. So if I have an angle in standard position, so initial side on the positive x-axis. Oh, good question. So they all start at the same spot. They all start in standard position. And so when I say that they share a terminal side, when they are coterminal, that means the angles would begin and end in the same place. Yes, they're always going to begin on the positive x-axis, and then to be coterminal means that they end in the same spot as well. Yep, good questions. Good questions. All right, so we're going to start on the positive x-axis, and I want to rotate around until we hit the negative x-axis. If I was describing this in radians, how far has that rotated? Pi radians, yes. Jay, hopefully this will clear it up a little bit. If I wanted to describe a coterminal angle with pi radians, we still start in standard position. It still needs to end over here on the negative x-axis, but maybe instead of going clockwise, I went counterclockwise to get there. How would I describe that rotation? Negative pi, yes. So negative pi radians is coterminal with pi radians. What about, I start on my initial side, I start on the positive x-axis, and I go a full rotation and then back around again, the negative x-axis, and I stop there. So same beginning position, same ending position. Absolutely correct, Kalia. That would be 3 pi radians. Those 3 angles are all coterminal. They have the same beginning and ending position, different number of rotations and or different direction, but same beginning and ending position. Does that make sense? Did that help clear it up a little bit? Awesome. So remember, to be coterminal with a particular angle, we would have to make a full rotation in either the clockwise or the counterclockwise direction so that we can end in the exact same spot. Let's go look at a couple of examples. We're going to find some coterminal angles. We're going to find 2 positive and 2 negative coterminal angles for each of the examples that I have up here. Question though, before we get started with this, one full rotation would be how many degrees? If we were talking about full rotations in terms of degrees. Yes, 360 degrees. How would we describe a full rotation if we were describing it in radians? 2 pi. What about 2 full rotations? What would that be in degrees? Awesome. Yes, Brendan. Yes, yes, yes. 720, if we were describing that in degrees, would be 2 trips around our circle. Or if we're talking about that in radians, that would be 4 pi. Awesome. Okay. For each of these examples, we're going to find 2 positive and 2 negative coterminal angles. So 50 degrees, just draw myself a little reference sketch here. 50 degrees would be in what quadrant? First quadrant, yes. 50 degrees, going to be right about here. Going this way. I want a coterminal angle with 50 degrees. So if I wanted another angle that started on the positive x-axis and ended in the same position, and I want a positive one, I could take a full trip around and end in the same spot. How would I do that mathematically? That's absolutely correct, Jay. Tell me how you got that. Brendan, that is correct. Tell me how you guys are getting that. 1 full rotation. So what are you doing? Tell me mathematically what you're doing to get that. Yes, you're going to add 360 degrees to that original angle. And so we get 410 degrees. That would be coterminal. How could I get another positive coterminal angle? Add 360 again. 2 full rotations. So I can either take that 410 and I can add another 360 to it. What could I do to that original 50 degrees to get a different coterminal angle? Add 720. Absolutely correct. Because that would be the same as adding 360 again. What do we get if we do that? $770 degrees. Love it. All right, so we found our 2 positives. Let's find our 2 negatives now. How could I find one negative coterminal angle. Same starting position, same ending position. Yes, Miles, that's absolutely correct. Jay, that's correct. Yes, yes, yes. I can take that original 50-degree angle. I can go in a counterclockwise direction. So I can subtract 360 degrees from that. And so that would give me what? What would a negative coterminal angle be? Negative 310 degrees, yes. Love it. Oh, I forgot the negative. Oops. I wrote the 310 part, but not the negative part. There we go. All better now. How can I find a second negative coterminal angle? Minus 720, yes. 50 degrees, minus 720 degrees. So what is another negative coterminal angle? Negative 670. Love it. You guys are rocking this. I want you guys to do part B on your own, 2 positives, 2 negatives, and I want you to give me your 4 answers in the chat. Here's how I want them in the chat. I want them from smallest to largest. I want you to find 2 positive and 2 negative coterminal angles for B, and I want you to list your answers in the chat from smallest to largest. So I want the negatives first, and then I want you to end with the positives. Max, that is correct. Brendan, that is correct. Kalia, that is correct. Coming in pretty quickly in the chat, so I'm gonna have to scroll back and look a little bit. Miles, I don't see your negatives, but the 2 that you wrote down for the positives are correct. All right. Let's go through them real quick, just so that you have a chance to check your work against mine. But everything that I've seen so far has been correct. So smallest would be negative 555, and then negative 195, positive 525, and a positive 885. And that's what I saw come through on pretty much everybody's. Okay, let's look at part C. Do I use the exact same process on C? Am I gonna add 360 or subtract 720? If it's different, tell me how it's different. If it's the same, tell me it's the same. Ah, 2 pi. We could convert it into degrees first, but I want to stick with the units that they gave me. So I like the idea of like adding and subtracting 2 pi. So if I did 8 pi over 5, I could add 2 pi to that. That would be a full rotation. Only one problem. 8 over 5 is a fraction. Whenever I'm working in radians, I don't want to have decimals. Jay, I like your idea. We can change the 2 pi to 10 pi over 5 so that I have common denominators, and then I can add them together. So plus 10 pi over 5. So what would a positive coterminal angle be then? (18 pi over 5). Yes. So there's one positive coterminal angle. How can I find another one? (4 pi). I can add 4 pi to it. 8 pi over 5 plus 4 pi. Same issue as before. Ooh, I like this. In the chat, I'm seeing I can add 20 pi over 5. 8 pi over 5 plus 20 pi over 5, so that I have that common denominator. So what is another positive coterminal angle then? (28 pi over 5). Love it. How can I find my negative coterminals now? How can I find my negative coterminals? Subtract 2 pi. Yep. So 8 pi over 5. I'm going to subtract 2 pi, which means I really want to look at this how. I don't want to write that down as 2 pi. I want to write that how so that I can actually do it. Minus 10 pi over 5, yes. So what is a negative coterminal angle for me then? Negative 2 pi over 5. Yep. And what about our last negative coterminal angle? How can I find another negative coterminal angle? Minus 20 pi over 5. Yes. So we're going to subtract 4 pi, which is the same thing as minusing 20 pi over 5. So what would my other negative coterminal be? Negative 12 pi over 5. Love it. All right. Part D, I want you guys to do on your own. 2 positives, 2 negatives. Let's keep it all in radians. Just like before, I want you to give it back to me, smallest to largest. Don't worry about trying to type the pi into the chat. Just give me what the ratio is, the fraction. I know that pi is in the numerators of all of these. So I want your 4 coterminals, smallest to largest in a single list. Just give me the fraction part. I know each one has pi in it. Max, you got 3 of them right. One of your negatives is wrong, though. There you go. Now it's better. Simon, check yours again for me. Jay, that is correct. Brendan, check yours again. Brendan, you do have some correct ones in there. Miles, almost. 3 of them are correct. One of them, you've got the correct numbers, but you've got it written as a positive instead of a negative, and so it's out of order. Jacqueline, one of yours is incorrect. Luke, that is correct. There you go, Miles, you got it. Okay. I'm going to go ahead and put these up so that we can move on to the last piece that we need to cover today. There you go, Jacqueline. So from smallest to largest, you should have had negative 11 pi over 4, negative 3 pi over 4, positive 13 pi over 4, and a positive 21 pi over 4. Those should have been your 4 coterminal angles, 2 positives, 2 negatives. Any questions for me about this? Right. Last thing we need to talk about today is arcs. We need to talk about arcs. So our arc length formula is S, that's our arc length, equals R, the radius, times theta. I'm going to draw a quick picture here so that we've got a little bit of reference. So on my circle, here's my radius R, S is the length of the arc, and then theta is the measurement of the central angle. If I want the area of that section, so not just how much crust is on it, but how big is the piece of pie, the area formula is A equals 1/2 R squared theta. And then there's one really, really, really important thing about both of these formulas. The theta in both formulas must be in radians. Has to. These formulas do not work with degrees. The reason that it has to be in radians, we talked yesterday about how radians is technically not a unit because it's ratio and the units cancel out. Degrees are units. So if we try to do this with degrees, we're actually going to have degrees as part of our answer, and we're looking for distance or area. And so degrees shouldn't be part of that at all. And the way we get around that is by making sure that our central angle has been measured in radians. All right, I want to look at these two examples here. First example is arc, a circle arc of 10 centimeters. So that's the arc. That means that is S. Subtends, or like goes around, encompasses a central angle, theta, that measures 4 radians. Find the radius of the circle. So I'm going to substitute it into my arc length formula. I would have 10 centimeters is equal to, we don't know what our radius is, but then we're going to take that and we're going to multiply by theta, which is 4 radians. And remember, radians don't technically have a unit, so our final answer is going to have the units of centimeters on it. How do I find my radius from here? Ten divided by 4. What is 10 divided by 4? 2.5. So we'd say our radius is, I need units on this because we got a story here. 2.5 what? Centimeters. Yes. All right, let's look at our next example. A circle arc of 24 feet subtends the central angle theta 34 degrees. Find the radius of the circle. 24 feet is what? Like I would put that in the place of what variable? 24 feet goes in for S. Yes. Because that is my arc. They gave me a central angle theta. What do you guys notice about that central angle theta? Not in radians, it's in degrees. So what's the first thing I need to do in this problem before I substitute anything into either one of these formulas? I have to convert it. All right, so I'm going to take 34 degrees. How do I take 34 degrees and convert it into radians? I know I need to multiply it, but what do I multiply it by? Pi over 180, yes. Pi over 180 degrees, that'll make my degrees cancel out. Now we're going to be in radians. So I'm going to have 34 pi over 180. You're welcome to reduce that, but we're just going to use it and substitute it in. And once I have that 34 pi over 180, it's in radians now. So now I can take it and substitute it into my formula. 24 feet equals R times 34 pi over 180. How do I take it from here and solve it for R? Multiply by 180 on both sides, okay? So times 180 times 180. That'll make that cancel. What's 24 times 180? $43.20, okay. So I have 4320 feet equals 34 pi r. Where to from here? Kind of ran out of room, so I'm going to swing it around. What do I do after that? Divide by 34 pi. Yes. I'm going to divide both sides by 34 pi. Since we're talking about a measurement of feet, I'm not going to leave this in exact units. We're going to go ahead and round this. Go ahead and round it out to 3 decimal places for me. Our radius would be approximately how many feet? I think you forgot to divide by the pi part, Miles. You got to include the pi in that denominator. Jay, no, I got something quite a bit smaller than that. Double check how you're putting it into your calculator. Some calculators are real picky about like pi needing to be inside parentheses. Yeah, remember, pi is in the denominator. There we go. Simon, Brendan, yes. Brendan, except I want 3 decimal places. This should be 40.444 feet. Be really careful about how you put this into the calculator. Some calculators will automatically just assume that you're multiplying by pi instead of pi being in the denominator. And so that's what could be throwing things off. I want to talk about one thing real quick. We won't get through it, but I at least want to start beginning to think through it. Don't forget, you guys do have homework due for me tonight. 6.1 homework is due tonight at midnight. You have an unlimited number of attempts on that, and it is completely auto-graded. All righty, so on this problem here, it says the tire for a car is 24 inches in diameter. So if this is my tire, here's my diameter, 24 inches. How big would the radius be? "12 inches, yes. We are trying to find the exact number of revolutions, so full rotations. I think a full rotation, how many radians is that? If I make a full rotation, how many radians is that? Close, Brendan. 2 pi, there we go. So if I'm thinking about that arc length formula that we were just looking at, that means S, the arc here, would be 12 inches times 2 pi. So S would be 24 pi inches. That is 1 full rotation in inches. I have the speed of the car as 60 miles per hour. And I want to know how many full revolutions it makes per minute. Well, now that I know how many inches are in a full revolution, I can convert that speed into inches per hour and then into inches per minute, and then I can convert it into revolutions. Please let me know if you guys have any questions while you're working through the homework tonight. Send them to me on Canvas if you get stuck on anything. Remember, you have an unlimited number of attempts on the homework. So if there's anything that you can't figure out, send me a message and we'll take it from there. I hope you guys have a fantastic rest of your night, and I will see you guys tomorrow. Have a good one, everybody.